I've been lucky enough to be in this fantastic laboratory for the last 32 years. We're leading in planetary exploration, but also in astrophysics, solar physics, space plasma physics. So we have some fantastic work going on here. The unique thing about this laboratory is that we have scientists and engineers working very closely together.
Here we have a CAD model of the rover itself. This gives us an idea of where we sit within the system, so we can have a look at fields of view and things for our cameras and make sure that nothing's obscured. The 3D printed model is a selective laser sintered representation of the optical bench. The 3D print is very useful for us because we can produce something full size and we can actually start getting a feel for how the system will go together, how we can handle it, wire it up. A lot of hands-on work. We had this produced with all the subsystems in less than a week.
So what we've just been doing here is really exciting. It's machining for the PanCam optical bench, the engineering model of it. So this is one of the models which gets delivered to the European Space Agency. So the project has really reached a very exciting phase. So what we're using here is a state-of-the-art numerically controlled machine, which is really the top in its class. But there are other machines here as well, which you would find in any mechanical workshop in different places, much more traditional types of lathes and milling machines. So these are the types of things which are used for the work that we do, not only in planetary science, but also in space plasma physics, solar physics and astrophysics. So it's a very exciting state-of-the-art mechanical workshop.
The filter wheel has just finished its environmental test. We've been testing the filter wheel at the Martian environmental temperatures, minus 120 to plus 80 degrees C, and the test is now complete, and I'm just here to take it up to the integration lab to do some tests. Here we have an example of a filter wheel that we have been using in some of our testing. These filters have different colors, which means they're sensitive to different wavelengths.
For me personally, I've been trying to get something onto the surface of Mars since 1999, when we started working on Beagle. So now this is the opportunity and sort of building really on that experience and building the team to actually send what is the best scientific camera to Mars. It's a fantastic opportunity. The science of this mission is going to be really fantastic. There are some engineering constraints on landing on Mars, which means you have to be fairly equatorial.
Equatorial, of course, because we're a solar-powered mission, and around the equator you have more of the sunshine more of the time during the year, so you want to make sure you can stay powered up for most of the time.
And we can't wait really to get it to the surface and to be able to have the rover roving around looking for sites to drill. PanCam will be playing a central role in the selection of exactly where to drill, so it will be able to do that with wide-angle cameras. And then combining that with a high-resolution camera, that will be a fantastic opportunity for geology and also atmospheric science.
Indeed, and from these stereo cameras we'll get good digital terrain models, that is, really details of the topography around us.
In terms of the big picture, finding life on Mars would be one of the most fantastic discoveries of the next decade.